Hi, my name is Dan Winter, and I'm going to demonstrate why the carnival ride Gravitron allows a rider to be lifted off the ground working against gravity. I'll start with a simpler example involving two blocks being pushed by a large enough force on M1 so that M2 does not slide down. The free body diagram shows forces in the y direction that must cancel each other. The friction force pointing up must be equal to or greater than the force of gravity in order for the block not to slide. Force of gravity is always constant in this case, but force of static friction can change, which is why this phenomenon works. The force of friction depends on the static friction coefficient μs and the normal force exerted on the object and is equal to their product. Since μs does not change, force of friction changes with normal force. As normal force gets bigger, so does friction. The normal force is equal to the force block 1 applies to block 2, which is directly related to the force on block 1. This is why, with a large enough force applied on block 1, block 2 will stay in contact with block 1 without sliding down. When we look at the Gravitron, people inside are experiencing the same forces felt by block 2. There's a normal force pointing toward the center, friction force pointing up, and force of gravity pointing down. Just like the example, the force of friction must cancel the force of gravity of the person for them not to slide down. The force of friction again depends on the normal force of the wall pushing on the person, which is equal to the centripetal force generated by the spinning gravitron. The centripetal force creates an acceleration pointing toward the center of the gravitron. The magnitude of the acceleration the person experiences is equal to their velocity squared divided by their distance from the center of the ride. Since all other variables, mass, distance, gravity, and coefficient of friction are constant, velocity is the sole interpreter of whether or not friction will be large enough to overcome gravity. So once you reach a high enough velocity, you will stick to the wall without sliding down. These equations show how we can find the minimum velocity required for friction to overcome gravity. The friction force is equal to μs times normal force. Normal force we found was equal to the mass times the centripetal acceleration of the person. Centripetal acceleration is equal to v squared over r, which we substituted in, and we also equaled the whole thing to gravity, which is mg. So we can cancel out mass and solve for velocity minimum, which is now equal to square root of distance r from the center times gravity divided by μs.